Today we talk about an alternative to using the binomial distribution or binom CDF. Instead we're going to use a normal curve, which is going to turn out to be a normal CDF. Let's take a look first at the probabilities, the basic probability chart. If we're going to toss a coin 10 times. If we're going to toss a coin 10 times, that makes little n equal to 10. It makes little p equal to 0.5. We'll define success as the probability of getting ahead. And we can calculate all of these probabilities using our formula that we've already seen. But instead of calculating those probabilities, just let's think of the size of each of those numbers. The smallest number in this is a 0.00098, and I've got one of those here and I've got one of those here. What I'm going to do is I'm going to make red lines in here that shows the smallest numbers with small lines. The biggest numbers will have longer lines. So when I go to the center of the chart here, I see a 0.24. So I've got a longer line for that, and that's the longest line I should have. As I go down from 0.24, I'm going to see this kind of pattern: 0.20, 0.11, 0.04, 0.009, and the smallest one of all, 0.00098. The same thing happens on the other side of that longest line. I got a line about that long. 0.11 would be about half as long. 0.04 maybe up to there. 0.097, etc. So you see those red lines, and they're giving me a gauge for how big these probabilities are. What I'm going to do is I'm going to turn all of those red lines sideways. Let me grab them first. Grab all those lines. I'm going to group them. I'm going to turn them sideways. And when you turn them sideways, you should be recognizing the pattern that appears there. What we actually have when we look at the tops of those red lines is something that approximates a normal curve. So I can use that normal distribution instead of the binom CDF to calculate any one of those probability numbers. Let's take a look at the curve if we draw it out in terms of a histogram, and these are calculated actually precisely. What I've done is I've said, okay, to get 0 heads out of 10, there's my probability. To get 1 head out of 10, that's the probability. And I graphed the height of each of those bars, and you can see now that we fitted a normal curve to that to those bars. So looking at this probability, now keep in mind it does not have to be perfectly symmetric like this. There are other cases where it won't turn out to be that way. Okay, a couple of restrictions on using that. If I'm going to use normal CDF for at least, at most, and that's what I'm going to use it for, the at least and at most calculations. If I'm going to use a normal CDF, then I still need to know what n is, I still need to know what p is, and I still need to know where r starts and where it ends. And in this example, I'll just say 0 to 3. But when I take a look at where r starts and r ends, now I've got a different set of numbers I have to use. I have to make a little adjustment. I'm going to go from r of 1 to 3. The adjustment I have to make when I'm going to the normal CDF is called a continuity correction. And all it means is that I'll subtract 1/2 from the lowest number, and I'll add 1/2 to the highest number. So if my r was 3 to 5, then my new range is going to be 2.5 to 5.5. I still need to know what n and p are. If my old range was 3,000 to 4,000, my r value, then my new r values are 2,999.5 to 4,000.5. So I'm just going to add 1/2 to the highest number. I'm going to subtract 1/2 from the lowest number. I'll use those as my new lower and upper bound. A couple of other considerations. We know what n and p are, but we're going to have to multiply them together to find the mean. You can see right there your calculator screen when you pull up a normal CDF. Lower bound and upper bound, that's we're going to subtract 0.5 from the number we had. We're going to add 0.5 to the number we had. The mean, and you're going to see this designation in your calculator. It's a Greek letter, another Greek letter, mu. The mean comes first. The mean is just whatever NP is. Now we were flipping 10 coins up here. 10 coins, and the probability of success was 0.5. So my mean in this case would be a 5. Just multiply n times p. The standard deviation is another little formula, a little bit more involved, but not so difficult. Square root of NPQ. Well, I've already figured out what NP is, so NP is 10. I've just got to multiply by Q. If P was 0.5, then Q was also 0.5. Again, I'm going to multiply 10 times 0.5, and my answer for square root of NPQ would be the square root of 5. And I would use my calculator function to find out what that probability was. And when I find out what that probability is, then it should be very close to what I got using the binomial CDF. And again, this is an approximation. The binomial CDF gives you exact values. It can give you exact values, but the normal CDF will give you an approximation. Okay, to the Inspire, and we'll work on a couple of these examples together.